Yeah, so I think 5.
Yeah, we did 4, although let me just mention this might not be obvious to a lot of people. Um, A minus B is always equal to the negative of B minus A. Okay? So if
Okay.
I want to turn that problem into a little bit of an easier problem, then I'm going to take a minus sign out, and I'm going to change the denominator to x minus 1.
Okay.
And that
So
really
then
was my first step. And that way, you
right. So
don't have to deal with any chain rule implications of saying that that's the natural log of x minus 1. You
okay.
still get minus natural log of x minus 1, and that can be changed into natural log of 1 over x minus 1.
Right.
Same thing. Okay. How about the next one, 5?
So 5,
Any ideas on this one?
I think we would do use substitution.
Yeah, good. I think the way your brain should always be geared is look for use substitution, if at all possible, as the first technique.
Yeah, I feel like that's the easiest one.
Well, and plus, if you miss it, you could spend 15 minutes. In other words, I missed it when I looked at this first. I didn't notice that the derivative of the inside is 2x plus 2,
Right.
and the numerator is x plus 1. So I didn't see it right off, and I spent a whole lot of time trying to figure out if that could be an arc trig function or something, and then finally I realized that that's the same as 2 times x plus 1, so I do have the derivative in the numerator, and I can do it by use substitution.
So would we just take a 1/2, put a 1/2 out front?
Yeah, well, let's go through it, because I'm not exactly sure what correction is needed. We're going to say this,
Okay.
which means du equals 2x plus 2 times dx. And yeah, I suppose that'd be the easiest thing to do, would be to put a 1/2 in front and then put a 2 in the numerator. Like that.
Right.
And then that is what we're looking at right there.
Right.
So I can change that whole thing to du. So now we have 1/2 the integral of du over square root of u. And that's
Right.
pretty straightforward.
Right.
Just the power rule.
Right.
Okay. All right. Let's see. That was that one. Let me put this over here. And I've got these all opened in order. The top of that, does that say a calculator can be used on this part of the examination?
I
Can't
think
tell.
it's non-calculator.
I don't think we need a calculator in any of these, but I was just wondering.
Yeah, it's non-calculator.
Okay, when I first looked at this one, I thought I saw a problem, but how are we going to go about this?
Well, so it's a differential equation or a diffeq, which is the same thing.
Well, it's something you're going to differentiate implicitly is what you're going to do.
Right. Okay, so
That's the thing to realize, is that you're going to differentiate this implicitly. I'm not sure it's not really a differential equation, not yet. A differential equation by definition has differentials in it, and this has no differentials yet.
okay, so then we just take the derivative of this.
Go ahead.
That would be 2x plus 2x dy or y prime plus 2y plus 6y y prime equals 0.
Okay, next step.
Next step is so we got to get the 2x and the 2y over onto the other side of the equation.
Okay, why don't we, while we're at it, get rid of all these even numbers. Let's make that a 1, a 1, a 1, and a 3.
Okay, so it's just, so it'd be minus x minus y.
On the right side.
On the right side.
And what's on the left?
On the left side is 1, well, x times y prime plus 3. Wait, yeah, x times y prime plus 3 times y prime.
Right. Now, what's next?
Then we factor out the y prime. So then x plus 3y equals negative x minus y. And then we divide x plus 3y on both sides. So then y prime equals negative x minus y over x plus 3y. So yeah.
What's the next step? Because this is a little bit of a strange problem.
So the next step, so what's the slope of the tangent line of the curve? So we have to plug in y, plug in what y equals.
Where? The bottom?
Well, we have to plug it into the first equation first to find the x value.
Yeah, exactly. In other words, you get x squared plus 2x plus 3 equals 2, correct? When I plug in y equal 1?
Yeah.
And that gives you x squared plus 2x plus 1 equals 0. And that gives you x plus 1 times x plus 1 equals 0.
Right.
So now...
So x equals negative 1.
And y is equal to 1. So now we can plug both of those in to our differential equation.
Right. So then we plug it in. So then it's negative 1. So just 1 minus 1, 0.
Don't even care what the denominator is.
Yeah, so it's just 0.
Well, I guess we do care. In other words, if the denominator happens to be 0 also, now you're got to do additional stuff. In other words, now it's an indeterminate. As long as the numerator is 0 and the denominator is not 0, then you're fine.
Right.
Okay, so I think C is correct. I think we did it correct. Method are we going to use to integrate this?
Integration by parts.
Well, that's what I first said.
Or actually use substitution.
Yeah, always. That's why I say always check U substitution first. Why?
Yeah.
Because we have the derivative of the inside, which is 2x, multiplying the function. That's exactly what we're always looking for when we're looking for that pattern recognition. So U equals
right. U equals x squared. Then du equals 2x dx. So then we're taking the integral of e to the u du 1/2 times
hold on, first of all, let's. We're going to do this the new way or the old way?
We can do it the
new way. You're used to the quicker way?
Yeah.
So let's put a 2 in front of that and a 1/2 in front, like that.
Right.
So now we see 2x dx.
Right.
So this whole thing is equal to the integral of e to the u du.
Right. And for evaluating purposes, I feel like putting it in terms of u would be easier, so you don't have to plug in the x squared. I mean, we're only working with one, so I don't know if that would be, but
I understand what you're saying. In other words, the new limits of integration would actually go from, notice the problem. Oh, no, hold on. No, it would go from 1 to 1.
right. Which,
And anything that goes from 1 to 1 is 0.
so maybe it is what they want you to do, and they want you to recognize that.
I don't know. I would say let's try it with the old limits of integration. And I have yet to see a problem where it really helps to put in new limits of integration. I just haven't come across one. To me, it's 10 times easier. Just go ahead and integrate that thing, and then before we evaluate it, substitute x squared for u.
Okay.
So what's the integral of that?
The integral of that is just e to the u.
So e to the x squared, which we're going to evaluate, minus 1 to 1. In other words, as long as I substitute back in before I evaluate it, then I can evaluate it at the same thing.
Right.
Now, what is that equal to? That's equal to 1/2 e
Minus. So yeah, I mean, we would have gotten it right if we just stopped at the u, but we wouldn't have been like for sure. We wouldn't have known 100%.
Oh, I see what you're saying. Yeah, we would have gone from e to the u from 1 to 1. Actually, I think that is 100%. That is always 0. And the reason is that it has to be. If you think about any curve at all, what's the area under the curve from that point to that point? There is no area under that curve.
Right.
By definition, at a single point. So you always know that if your lower limit's the same as your upper limit, it is 0. So it would have actually been a little faster to do it the way you wanted to do it.
Okay. I was just seeing if that would be a shortcut on the test for time saving.
It would have been a shortcut for sure.
Okay.
Okay, so let's get rid of that one. And I'm just going to go in the order that you gave them to me here, or you photographed them. And let me open this up. Remember how to do parametric derivatives?
Sorry. So parametric derivative.
So what's that equal to when you are working with parametric equations?
So dy dx is equal to dy dt over dx dt.
Perfect. That's the only thing you have to remember. Now, what is dy dt?
dy dt is 2t negative 2t sine t squared.
Good. And what is dx dt?
Dx dt is 2t.
So the biggest mistake I think one is at risk here is putting these in the opposite order. In other words, we're so used to doing dx. Well, maybe not. I'm used to having x in the numerator, but Actually, all derivatives are dy dx, so let me take that back. So the answer is
B.
Yep.
All right, so we're taking the derivative and finding where it changes from negative slope to positive slope.
Or there's an easier way to do it. And that's to take the second derivative, and if it's positive, it's open up, concave up. If it's negative, it's concave down.
So if it's
and we're going to be able to take the second derivative rather easily on that cubic function.
Right. Well, so if it's concave up, that means minimum, and concave down means maximum, correct?
Although it doesn't mean absolute, it just means relative. There's one more thing we're going to have to check before we can determine absolute, and that's the end points. So first of all, let's figure out where x is at a relative minimum or maximum.
Okay, so then we take the derivative. 12x squared minus 16x equals 0.
What does that mean? Let's divide everything by 4.
So then 9x minus 4 is the second derivative.
First of all, let's figure out where on x we have a zero slope tangent line.
Okay.
Words,
so should we factor that? What?
Let's solve that. We need to take that first derivative, set it equal to 0, and solve it. That's going to tell us where the x coordinate is.
Okay, so should we factor it to find the zeros?
Yes, that's what I was hoping you would figure out. In other words, some of this stuff is just algebra, but when you've been taking calculus BC for a long time, it's hard to remember some of your algebra. So, solve that?
I'm not really that sure how to factor that.
What's the greatest common factor on the left side?
On the left side, x.
It's left over.
3x minus 4.
Don't ever forget that fundamental rule of algebra, where it's if you can get something, one thing multiplied by another equal to 0, well, then now you've got 2 points that are possibilities.
Oh, okay.
So x can be equal to 0, or x can be equal to 4/3. At both of those places, we have a zero slope tangent line.
Right.
Now, in almost all likelihood, one of those is a minimum, one of them is a maximum. So that'd be the next step, is let's determine which one is a minimum, which one's a maximum. So now take the second derivative.
So the second derivative is 24x minus 16.
Which means 24x equals 16. Because we want where the second derivative is positive.
Right.
Which means x is
16 24ths or 4 6 2/3, yeah.
2/3. However, what we really want to know is we don't really want to solve for x there. Take that back. What we want to do is plug in the two x's we have.
Well, so 0, we already know it's going to be negative. Because if you plug it in, you get negative 16, so then that one's ruled out.
Okay.
So then 4/3
So 4/3 is a negative concavity. So So when x equals 0, we have negative concavity, which means maximum.
Right.
When x equals 4/3, second derivative is positive or negative?
Positive.
Which means it's concave up.
Which means a minimum.
Which means a relative minimum.
A relative minimum. So we have to test that.
That's the only relative minimum in the curve. So now how do we tell whether it's an absolute minimum?
We check the endpoints.
Okay. On which function?
On the second derivative?
No, on the original function. Remember that they are asking you about a minimum on this original cubic function.
Okay.
In other words, that cubic function might do something like this. Okay? And we can see that there's a relative minimum at 4/3. Right. But the interval goes from -1 to 1.
Right.
Tells us quite a bit. It tells us that that absolute or that relative minimum isn't in that interval.
Right. So that can't be an answer anyways because it's not in the interval.
The only thing that was in the interval was x equals 0.
Right, but then that was a maximum.
Yeah. So what now?
So we should plug in -1 in the first equation.
And to the original equation, we want to figure out what f of -1 is, and we want to figure out what f of 1 is. And we know that there's no place in between there that is even a relative minimum. So whatever gives you the lowest value here is going to be your answer.
Right.
So what's that? -4 minus 8 is 12 plus 1. That's -11. What is this? 4 minus 8 minus 4. That's -3. Looks like that's it right there.
So would your answer be -1 or -11? Because it says at x equals, so I think it's -1.
Yes, you're right.
Okay.
You're absolutely right. In other words, and the wording is extremely important on these. In other words, if they'd have said, what is the absolute minimum, then they're talking about the y value, or the f of x value. But specifically say it has an absolute minimum at x equal, and you're right, it's x equal -1 is where we found that. Let me rewrite this just so we're dealing with. We don't need to rewrite it. Factor the bottom.
So x squared plus 5x plus 6. So x plus 3 and x plus 2.
In other words, a problem like this should be fairly immediately partial fractions.
Right.
Solution. Yeah. It's not u substitution because we got a 2x plus 5 as the derivative of the bottom.
Right.
Okay.
So then x on top, so then a times x plus 2. and then b times x plus 3, and then equals x. So then plug in -2 to get rid of a. So then that's b times 1 equals -2. So then b equals -2. And then plug in -3 to get rid of b. So -3 equals -a. So +3 equals a.
All right, so we got our b and our a. So a is 3, and that's 2. Now integrate those two things on the right.
Okay, so the integral of 3 times the integral of 1 over x plus 3. Well, so 3 times ln x plus 3 plus 2 ln x plus 2.
And notice that's not on there.
Right.
In fact, every answer on there peculiarly has an exponent, which, oh, I see why. Okay. So how can we turn this answer, since this answer is not on there, what more can we?
Right. Well, immediately I can cross out a and c because addition is multiplication with these, right?
Yeah, rather than take that path, let's go ahead and simplify this on our own. You need to know how to simplify that.
Okay, so then
what's the first step in simplification?
Well, it'd be ln x plus 3 to the 3rd power.
Right. In other words, move those coefficients up top instead of in front. That's always the first step. Okay, I'm going to put it out. I'll put it inside like that. This one was a 2, right?
Yeah.
Okay, now combine the two log functions. Because none of these answers have 2 logs. They all have 1 log.
Right, so then it's ln x plus 3 cubed times x plus 2 squared plus c.
Which looks like that right there.
Yeah.
All right. We're moving right along today. Oops, not really. Just looked at the clock. You good to go? You want to do one more? I don't care.
We'll do one more. Yeah, I don't have anywhere to be.
It's a derivative, so.
Yeah, I think this one is a little confusing anyways.
Okay.
So, for this derivative, usually I write the sine squared x function as, so I write x squared out front and then times sine x all squared. Would that make it easier or harder?
It doesn't really matter. The key on this is what you're going to let u equal.
Okay.
In dealing with that. In other words, we don't have any problem dealing with the x squared. That's not going to give us any problems. But what are we going to do with sine squared x? How do we differentiate that? What is u equal to?
U would be equal to sine x.
Good. Whereas if it was sine of x squared, u would be x squared. So that's the difference.
Okay.
Okay.
And
then, of course, if it's sine of x, all of it squared, that's the same as this. So you got to be a little careful. There's 3 different ways to designate that thing. 2 of them are the same, and 2 of them look the same. So you have to be a little bit careful. Okay, so let's apply what rule?
The product rule.
Okay, so get me started on it.
So then x squared times cosine squared x plus.
If if u is going to be sine x, then this thing we're looking at is u squared.
Okay. So
how would you differentiate u squared?
Well, u squared would be 2u.
Okay, so that's 2 sine x. Now you need du.
2 sine x times cosine x.
Right. That's the first part of the product rule. Plus?
So then plus sine squared x times 2x.
Now let's see if we can find an answer that matches that. Well, I think it's got to be one of these at the bottom. Let's see, that looks like it almost matches it. Ah, it does match it. They just turned it. Oh, it's this one. Okay, let's see. Can we simplify that any?
I'm not sure.
Well, God, except I don't see it simplified anywhere. We can definitely do some factoring. I mean, I could factor out an x, I could factor out a 2, and I could factor out a sine x. Let's try doing that. Right? In other words, there's an x squared, there's an x, so I can definitely, and there's a 2 in both parts, so I can definitely, and there's a sine x in both.
Right.
So what does that leave? That leaves x times cosine x plus sine x.
Right.
That times that is that. I don't see the other one though. Ah, notice the one difference between that answer and the others. The sine of 2x.
Right.
Not the sine of x. Same thing with that up there. Okay, and that's important because we know the sine of 2x is equal to what? What's its identity?
Sine of 2x is equal to cosine x.
It's actually equal to 2 sine x cosine x. That is the double angle identity for sine x.
Okay.
Okay. Now, notice what that is right there.
So they just changed it with
that's sine of 2x, right?
Yeah.
So let's replace that. Let's go back to the top line. And we've got x squared sine of 2x plus 2x sine squared of x.
Okay, and then that matches D.
It does, exactly. Yeah, that was tricky.
Yeah.
Because you have to recognize the double angle formula in reverse. In other words, what was necessary was to recognize that that is the sine of 2x.
Right.
Now, I suppose you could, if you were in a pinch here, you could take your double angle formula and substitute it in there and see if you get something similar, and you wouldn't. But by the time you got down to D, if you substituted it in there, you would. You'd see exactly what you have.
Right.
So you can always do a little bit of back solving on this. You don't necessarily have to recognize what the double angle identity is, but it's helpful.
Right.
All right, John, I will let you take the rest of your day off.
Okay, thank you.
Enjoy. You're welcome. Talk to you later.
Talk to you soon.
Bye-bye.